Sanjay, I'm audible?
Yeah.
Something, good morning.
Yeah, good morning.
Tell me, screen is visible?
Yeah, visible.
Okay. Now, today's topic is we are going to learn about how many types of 3D printing technologies are. Okay. Now, see, first I'm telling you the names of the technologies, then we are going to deep in it. Okay. Shall I show you the videos also and theoretical portion also? See, for 3D printing, we are using generally several methods. The first one is direct energy deposition. This is known as DED. You can say direct energy deposition. Okay. Second one, and inside these also we have some options. But first we are going to see how many types of technologies. So the first is DED. Second we have LPP, that light photopolymerization. LPP. This is light photo polymerization. Okay, this is our LPP. Then third one we have ME. This is known as material extrusion. Material extrusion. Okay. The fourth we have PBF. That is basically known as powder bed fusion. Okay, this is also a 3D printing technology in which we have sheet lamination. The fifth one, SL, sheet lamination. Then the sixth one is BJ, binder jetting. Okay, and the seventh one is we have material jetting, MJ. Note it down. Okay, these are the many various type of 3D printing technologies in which we have separate technologies too. Like if I'm talking about the direct energy deposition, in which we have three types of energy deposition. First is electron beam, second ion fusion, then laser powder forming. Now I'm saying here EBDM, electron beam direct manufacturing. Electron beam direct manufacturing. I'm taking shortcut, okay? Manufacturing. Now, second in this, ion fusion. third in this laser powder forming. Okay, here are the three things we are learning into direct energy deposition. These are the three techniques for the direct energy deposition. Then we have light photopolarization, in which also we have two. Okay, the first one in this digital light processing, DLP. Digital light processing. And second in this we have SLA, stereolithography, the oldest one. Stereolithography. Okay, these are the techniques in LPP we are using. For material execution, we are using FDM. FDM performance fuse deposition modeling. Generally, we are using this one, fuse deposition modeling. Okay. Now, various techniques are available into powder bed fusion. Here we have multiple. Like what we have in the powder bed fusion, we have direct metal laser setting. Laser sintering. Second, electron beam melting, EBM. Electron beam melting. Then we have SHS, selective heat sintering. Selective heat sintering. Then we have selective laser melting, SLM. Selective laser melting. And in this we have last laser, selective laser sintering. Selective laser sintering. Okay, these are available into powder bed fusion. Then in the sheet, we have only single one, or sorry, one we have in this also. LOM and UAM. LOM, its full form is laminated object manufacturing, MFG. Okay. The second one is known as UAM. Its full form is ultrasonic. Additive manufacturing, MFG. Okay. Then boundary jetting and material jetting. These are the total techniques we are using into 3D printing. Okay. If I'm talking about first option like EBDM, so if you want to note it down now, please note it. What is it basically? What is happening in this? I told you that if you want to write it, you can. In the direct energy deposition, see, this is the process of basically direct manufacturing. Okay. Direct manufacturing is a process that melts metal wire to be used as feedstock to form an essential component found within a vacuum chamber. Please note it down. Direct manufacturing process that melts metal wire to be used as feedstock to form an essential component. Vacuum chamber. Okay, with EBDM material in wire form, it's fed into the molten pool created by an electron beam. Now I show you into the video what is the electron beam. Direct manufacturing. Electron beam. By using electron beam, they're going to melt the material that is basically in the wire format. Direct manufacturing or additive manufacturing, both are same. Let's see the video of it. See, this is a type of printer. Here wire is available. This is a vacuum chamber in which it is going to be print. See here, we have nozzle. This is wire spool. Here we have electron beam, this one. With the help of this, the material wire is going to be melted. And go to the nozzle, and from this nozzle it's going to be print. See, this is a wire comes from the nozzle, and this is going to be melted by using this electron beam. And what design you want to print, you have to give that drawing into the printer. It is going to print that. Is that clear?
Yeah.
Let's electron beam portion. How the printer is going to be work. Okay.
Yeah.
Now, next, what material we are using in it? We're going to do paint. In EBM, what type of material we are going to print? Okay, please note it down. Material are using basically for EBDM. I'm typing here EBDM. What kind of material we are using in it? So first we are using titanium. Okay. Second, we can use tantalum. stainless steel we can use. Inconel, aluminum alloy, nickel based alloy, or you can say nickel alloy, titanium aluminite, or you can also use matrix composition. Okay, including titanium also. So these are the material we are used into EBDM. Okay. Is it clear?
Yeah.
Okay. Now the second we are having here ion fusion. Okay. Now first I'm telling you what is the material of it, and then I'll show you how it is going to work. IFF. Note it down the material. In this we are using steel alloy, nickel super alloys, and you can use any material which is in the powder form. Okay, or wire or powder form. We can use that also. We are using to IFF. See what is the process of the IFF? You can see here. Ion fusion. Video is not available. No. Now see, I'm telling you by using paint. See, in IFF generally what happened, I'll see just here, suppose we have one platform. Okay, besides of electron beam, here we are using plasma arc. Okay, both the process are same. But when we are going to take it here, suppose we have one object from here and the second object from here. See, generally this is known as our wire, and this is in the in the EBDM, it is the electron beam. Okay, the melting process is from electron beam, but here we are using plasma arc. What we're using? Plasma arc for melting the wire and going to print any kind of part here. Okay, clear?
Yeah.
Only the difference is, besides of electron beam, in ion fusion we are using plasma arc, or you can say, you can write if you want to do, in ion fusion formation. Ion fusion formation is a process that melts metal wire or powder using plasma welding torch to form an object. Okay, you can write down also. Ion fusion formation is a process that melts metal wire or powder using a plasma welding torch to form an object. A plasma of heated organ ions impel metal from a wire or powder. Okay. But if I'm talking about this process now, this process is very cheap. If I'm talking about a comparison about IFF or EBDM, electron beam direct manufacturing, IFF is a cheap, but it is a slow process. Okay, as compared to our next portion, that is laser powder forming or electron beam manufacturing. See, here we have, in this we have three techniques now: EBDM, ion fusion, laser powder forming. The slowest process is ion fusing. It's a cheap and slow process as compared to these two. Okay, you completed this portion. You write it down all. Can I remove it?
Yeah.
Okay. I'm going to open a new. Now see, next we have LPF, laser forming. First we write it down, what material we are using in it, LPF. Hello, am I audible?
Yeah, audible.
Okay. Now guys, we have LPF. Now please write it down, the material we are using in it. Any kind of nickel we can use, so that we can take in variety of nickel. Iron, cobalt, titanium based alloys, or you can say titanium alloy. Okay, or you can use ceramics also. Ceramics means ceramic metal composition. I'll type for you. Ceramic metal composition. Okay, we can use these materials for LPF. What is LPF? It is also the same process, but rather than electron beam or plasma welding torch, we are using in it laser. Okay, the process is same. Here we have also the same process. We have one part here. We have bed. On bed, this part going to be, we are going to print. Okay, so we have here one laser, and here we have the wire. This is known as wire. Any material you can take for the wiring, and this portion is known as laser. Through laser, it will melt in this. This is okay, and then this part will be created. Now you can write down it. What is the process basically? Laser powder forming can be used to repair or add volume to pre-existing model. Okay, in this, what we can do also, we can add the material to a pre-existing model, or we can repair also, because it's a powder based portion. Okay, so it is not a wire basically, it is powder. Okay, from nozzle we get the powder and going to be melt that and create a solid. A laser is used to melt the surface of the target area, while a stream of powder metal is divided onto the small targeted area, creating a melt pool. So with the help of laser, we can melt the powder surface area and create a solid portion. Okay.
Yeah, okay.
Now we have the next type of 3D printing, that is our LP, light photopolymerization, LPP. Okay, in this we have what? First is digital light processing. Now you can see into the example. Oh, sorry, did I tell you in previous paint file? Second is light photopolymerization. In this we have digital light processing. Okay, that is DLP. So first note it down in the DLP. DLP, what is the kind of technology is this? So DLP uses a projector like the kind used for office presentation. They are using the projector na, in the theater or office purpose, for seminar they are using projectors. So this type of projector we are using into light processing. Okay, to project that image of the cross section of an object into a vat of polymer. Okay, through with the help of projector we do that. Now let's see if process is available into YouTube or not. Digital light processing. Now see, DLP 3D printing process is there. See, this is the basically example of it. Here we have projector, and this is the image. They are going to print and go to the polymer, and then it will create a 3D. Okay, or we can use in this proper is not given. No, see, the skeleton head is going to be created. This is a proper video. This one. See, this is a type of printer. In this, we have the image. It is going to be go to the liquid polymer. And it is printing. See, it is a moving table. See, in the bottom we have projector, which gives the image to our polymer to print that. Like this is working. See, image is flashed there in the polymer. But no shows the part now. Shows in this. This is the printer. See, this is liquid polymer filled. See, this part is going to be print on it. So this is on Revit host basically, and it is attached with the 3D printer. And now it is going to be print with the USB cable, USB device. The settings on the 3D printer. The filter in the below. See, it is going to be print, and when it is now see, our part is ready with digital light processing. Okay. Is it okay? This is our digital light processing. See, for creating a ring, they're using this one. Okay. This is a DLP. Now we have to write what type of material we are using into it. You can write DLP printer can produce objects with a wide variety of properties such as water resistance, flexibility, durability, stiffness, high clarity, thermal resistance, and high impact resistance. This type of part it will create. Okay, the water resistant part, flexible, durable, stiffness is the properties of the object in which is made by DLP. Okay, now please write out on the material here used. We are using here ABS, polypropylene, wax. Okay, we can use this material into DLP. Okay, Sanjay.
Yeah.
Then next in this we have one more thing, that is SLA, stereolithography. The both techniques almost same, but in this DLP, what is the there? What we are using here? Projector. Yes, for giving the image. But in this SLA, we are using laser. And what material we are using into? It is created by
SLA full form.
stereolithography.
What?
Stereolithography. In the previous page, I already written na SLA, stereolithography. This is
Yeah,
the
okay.
oldest technique. In which what will happen? It uses a laser to draw each layer of the model into a photopolymer. Okay, by using resin, curing it one layer at a time, a beam of UV light into the form of a laser is projected onto the point in the resin, causing it to react and become solid. Okay, so one by one layer will be created into stereolithography, SLA. Okay, here we are using laser besides of your projector, and we are using the material. I'll show you the printing techniques also. I'll show you this. You can type here. Both are almost same. SLA. See, this is the introduction of lithography. I'll show you the. This is the same type of printer. See, one by one, the laser is going to be on that particular area, which model we are going to print, and it is going to react with our polymer and convert into solid. That particular area. See, this model is going to print. So every layer by layer, it's going to be react with the laser and convert into solid. See, every one layer is going to be print one by one, and it give you the proper object. See, this flower is going to be a print, but it will create a supporting portion also. So that you have to cut after printing. Okay. This anything you can create like this. See.
3D printing is a physical object.
Sorry.
3D printing. It's not a sheet. Yeah. It's a physical object.
I'm not getting you. What?
3D printing means it like sheet xerox or printing means I like that, but you show me a physical object. Oh,
It is created a physical object, no?
yeah.
It is not a sheet printing. It is a 3D part printing.
Oh,
Any part is
directly we can print into direct physical object, huh?
yes, yes, yes.
For more precious and accuracy object, we can use the 3D print modeling, huh?
3D printing modeling generally we are using to prevent our mold and casting. See, if you want to create one part only one part, okay. So if we are going for the previous types of printing like mold and casting, it is more costly. So we can use 3D printing nowadays. The single part directly we can create. Or now the 3D printing techniques are more stronger, so that part we can use also. Firstly, before sometimes ago, we can create only the prototype, but nowadays it create a working product. Okay, you can see the rings there, na? They are the working products we are using into this. Okay, the
Yeah,
sunglasses you can create with the help of this. Now, next we have material extrusion. Material we written in this, not it. No. Now, first written the material into SLA. We are used. This is also giving you the water resistant part. Flexibility is there, durability is there, stiffness is there, high clarity is there. Okay. Now the same material we are using into that also. The same ABS, polypropylene, wax. These all three also the same as ever. Material we are using into this. Okay. ABS, polypropylene, and wax. Please write it down. Write it down. Next, we have material extrusion. In material extrusion, we have the first technique is FDM, fused deposition modeling. FDM, fused deposition modeling. What is that basically? It is a easily understood as a drawing with a very precise hot glue gun. Here we have, generally we are using FDM here, right? I have also a 3D printer. I show you later. It is also used fusion deposition modeling. In this, we have a hot gun. Okay, and the wire is passing through that gun and it's converted into melt metal or melt wire, melt material, and creating a part with the help of that by layer by layer. Okay, fused filament fabrication we can also called. It is extruding the material through a nozzle to print a cross section of the object. Okay, cross section means layer by layer it will be printed. Now I show you the FDM process and I show you the 3D printer also. It is FDM is there also. No? FDM. The normal 3D printing process is this. See, this is a normal printer which is directly available into the market also. You can use this type of part. See, this is a hot gun. This is a wire cable passing through this gun and converted into melting. Then it is created a layer by layer cross section of your part and gives you a 3D model. This particular portion, this printer I have also. It's taking more time. Okay, it shows in the video is very less time, but it created more time. It's taken more time to create this part. Okay, so any part you can print, but they have to maintain the part, how it is going to be placed onto the bed. That is the main thing. That is we can understand into the software, that is Revit host. This is wire based portion. It is going to be print like this. Okay. Clear?
Yeah.
This is the FDM printing. So any part you can print on it. So first we had to create that part into our 3D modeling software, and then we have to give the printing file as G code file to our printer to print this file. Okay. Now you can write it down the material into FDM. ABS, PLA, and polycarbonate. These material we are using into wire format in wire. Okay, so that it is goes into the hot gun and it is going to be melt and then it's created a cross sections layer by layer. Okay, this is generally used for home printing. Okay, where generally we can create some normal parts for our home, so we can print through FDM. It is widely used because this PLM material is available directly. Okay, this is known as extrusion of the material. Now, similar type of printing is also there, that known as powder bed fusion. In this we are in FDM we are using wire. Now in powder bed fusion we are using powder besides of the wire. Okay, that technique is named here direct metal laser printing, DMLS. Okay, this is powder based. Okay, now I show you this first. Direct metal laser sintering. See, this is the DMLS process. See, we need to print this part. See, the laser is working on the powder and print the 3D part. See the clarity into the powder. See, in PLA, FDM, we have not enough clarity is there. Layers are visible there, but in powder, there is no layer. It is clean printing. See, this part is going to be print. Okay, it is based on the motion here. This is a 3D printer for your powder based portion, the MLS. After every layer completion, this portion is place the powder again. then again print, again powder is forming on the file, and again that's going to be print by using laser. We give the finishing to our part. Okay, this is a working model it will create. You can use it. Is it clear? DMLS, how it is going to be work?
Yeah.
Okay, now write it down in it. In DMLS. DMLS is a process that sinters layers of the powder metal in a chamber of inert gas. This process has been used exclusively by the EOS. When a layer is finished, the powder bed moves down and automated roller adds a new layer of the material which is sintered to the form of next section, which we see into the video. Na? When the first layer is completed, then the bed is moved down, and the second powder again we have to sinter on the one layer more. We have to powder layer we have to create with the help of roller, and then again it's going to be print with the help of laser, and again it's going to move down to create a next layer. Okay, that is the process into the direct melt laser sintering. Now, please write it down the material we are using into DMLS. Multi-component alloys you can use. Multi-component alloys you can use into this. Okay, which is basically on the powder form, and then you can use here stainless steel alloy also, or that component alloy contains what? This alloys basically contains stainless steel, aluminum, titanium, inconel. This multi-alloy component alloy contains these kinds of materials only. Okay, cobalt, chrome you can also use in it. Cobalt, chrome. Okay, that are the material we are used into the multi-component alloy. Hello? Hello?
Hello.
Sanjay? Yes, Sanjay. Now, what we completed? Powder bed fusion, no? DMLS.
DMLS.
After that, the second is in this bed fusion, we have second option is EBM, electron beam melting. What is electron beam melting? It's the same type of direct manufacturing of electron beam, na? It's a kind
Yeah.
of, but it is on powder based. That is not a laser based. Oh, sorry, wire based. All the things are same. See, you can write it down. Electron beam melting is a process that works by melting powdered metal within vacuum using an electron beam. The previous electron beam direct manufacturing, we are melting the wire. Here we are melting the powder only. Okay.
Yeah.
The same type of processing, but with the help of electron beam. Okay. In this also, once a layer is finished, the powder bed moves down, and automated roller add a new layer of material, and then again electron beam is going to be melt your powder material to create a new layer. The same layer type process what we see into this video na. In this, it is melting by the laser. See, but in this electron beam, it is melting by the powder. So sorry, electron beam. Okay. Now write it down the material in this EBM, electron beam melting. Pattern the material in this we are using. That is various form of titanium. You can use titanium. You can use cobalt. Okay, these two type of material we can use in it with high temperature. In high temperature. Okay, in EBM. Next we have selective heat sintering, SHS. What is that? So selective heat sintering systems are being manufactured by blueprinter. This is also thermal print head. This is also using a thermal print head which applies heat to the layer of powdered thermoplastic. Now we can see here SHS, selective laser, no, heat. Selective heat sintering, see, SHS. In this what happens? A thermal printer head is there to print the powder material. See, this is a powder. Fill the powder into the printer first. This company name is Blue Printer. Okay, SHS is created by Blue Printer. Now this car model you need to print. See, the print head is there. It is melt of material. One by one layer it will create. Okay. This is also powder based. The powder in the front of this machine. It will again it will go to create a new layer. Now see, like this it will create. Okay. This is SHS, heat sintering. In this material we are using SHS. Write it down. Here you can use similar material to nylon. Nylon you can use in it, or any kind of nylon material you can use. Thermoplastic you can use in it. Thermoplastic material. Okay, basically that is nylon. So any kind of thermoplastic material you can use into the SHS, which is going to be melted by thermal printhead. Okay. Next we have SLS. SLS gives us the laser sintering. Okay. In this we are using thermal printhead. Difference between these two. Okay, thermal printhead. And SLS we are using laser. Okay, for melting the material. Now I can show you that also first. The laser sintering. See, in the row boxes we have powder, and then this is leveler, and we can go the CO2 laser on the top. It is melting your powder base, and then again leveler is moving and fill the new layer, and again it goes down, then again new layer, again goes down, again new layer. Okay, this is how it is working. See, the leveler is here now, then this move down again, then from leveler from here to this side to fill the powder here and create a new layer. Okay, this is SLS. The same kind of technology, but by using laser. Okay, you can use a material into this, into SLS. The same material you can use in it also. Okay, the powder materials which are commercially available, you can use that kind of material here. Polystyrene you can use, carbon fiber you can use, carbon fiber, polystyrene. Polystyrene you can use in it. Okay. Next, what we have, SLM. These all type of bed fusion, powder bed fusion. SLM. What is SLM? Selective laser melting. The same kind of technique. Here we have also the same laser, powder, and level by level it is going to print. Okay. Material you can use in it, single component alloy, not multi in this. Single component. Single component alloys you can use in it. You can use here for single steel, cobalt, chrome, but only single component. Okay. Titanium, not a mixture. Aluminium. You can use into SLM. Okay. Tell me what we have next. After these all powder bed fusion. Hello, Sanjay.
Hello.
What is next?
Next,
What is the next technique?
next is sheet lamination.
Okay. You write it down all.
Yeah, sheet lamination and binder jetting, material jetting.
In sheet lamination, the two techniques are there. First is LOM. In LOM, what we have? Laminated object manufacturing. Okay, I can show it here. Sheet lamination. See. Laminated object. This one. So in this, what happens? We're generally using layering sheets of material 1/1. Okay, the one sheet below and then again a new sheet on the top, and we have to bind that two layers with the glue. Okay, the printer then slices an outline of the object into the cross section for it to be removed from the surrounding excess material. What will happen in this case? We have multiple sheets here. Okay, and then we have to join with the glue, and we have to surroundings material we have to cut from this type of 3D printing. Okay, that is known as LOM. Now, if it is available here. See, here we have layer one layer on the material, and we have to cut outside material, which is not required basically. This is based on the this is based on our 3D CAD model. Which material we have to take or which material we have to remove. Okay, so from the help of laser cutting, we can cut the material from it. This is known as our laminated object manufacturing. Okay.
Laminator manufacturing means it's also physical object or a printing.
Sorry.
It is also a physical object or a 3D.
It is a physical object. Layering sheets of the material. We had to place 1/1, and we had to combine them with the glue. Okay, so that will be great thickness, and then we have to slice outline. See here, 1, 2, 3, 4, 5, 6, 7, 8, 9 layers are there. Okay,
Yeah.
these are the predefined laminated sheets. Okay, that we have to fix together, and then we have to cut. Sorry.
That object made by glue, huh? Yeah.
Yes.
Okay.
Okay. And then outside cross sections one by one we need to cut, and then excess material we have to remove from it so that we get our part. Okay.
Yeah. Okay.
So here the sheet material will be used. That is our plastic sheet. Okay, shelf copy paper, plastic shelf, copy paper. They're using in LOM. Okay. This is the sheet material we are using. Then we have ultrasonic additive manufacturing, UAM. Ultrasonic additive manufacturing. It is also known as ultrasonic consolidation, UC. This is basically a welding process to secure strips of the material together, building up an object with a single sheet of material. It is created from a single sheet of material, and this is a welding process basically. In LOM, we are going to combine the sheets through glue. Here we have to weld. Okay.
Yeah.
The solid state welding process, UAM. The same copy paper we are using into this, but the material are different of the sheet material. That is metallic material, metallic material. You can use titanium, nickel, copper, tantalum. We can use these kind of material sheets to create by using UAM. Okay. Then next we have binder jetting. I show you binder jetting first here. It is available here. Binder jetting 3D printing. It is inkjet powder printing basically. We need to bind the powder here. So what we did in this case, we are spraying a liquid binder onto the bed of the powder for solidifying it. Okay, that is known as binder jetting. Every section, every cross section, we need to give the liquid binder on it. First, we have to see. You need to print this this part. You need to print. Now here we have powder. Then we have spread on it a liquid binder. Then again powder layer. Then liquid binder. Then powder layer. Then liquid binder. And layer by layer we can create it. Okay. It will give a liquid binder. This machine. Then the layer of powder again. Again, it is creating a liquid binder. Okay. Then you get this type of part with powder. Clear?
Yeah,
Binder jetting.
yeah.
What is the material you are using into it? Write it down, the material of it. We are using into the range of material for the flexible process. A different combination available for the pairing powder material with binder agent allows for the wide range of material properties. They are using into this composition of the material. Okay. Any metallic object you can create from it. So any metal you can take here. But in powder. Okay. Any composition you can take. In the last we have material jetting. I'll show you first material jetting. In this, what happened? The printers resemble the traditional paper printing in more ways than many other 3D printing processes. Into this, the printhead moves around. The printer is not shown into this solid set box. Under these UV lamps, it will create. Okay. It will blow the material into the polymer to create this part. And it's created a smooth part or flexible part will be created. Like you can create mobile covers from it. A silicon covers are there, na? You can create from this material jetting. Okay.
Yeah.
You can create it like a rubber material you can use in it. It will create a rubber part.
Phone back case, like
Sorry?
phone back case that like cover.
The phone back cases you can create from this material jetting.
Yeah.
Any flexible or any flexible material you can use in it to create the part. It is created through polymerization. Okay, the photopolymer liquid.
For NX, which printing is mostly used?
For
NX, new graphics.
I'm not getting what for
NXCAD, which printing you mostly used?
NXCAM.
Yeah.
See, NXCAM is a manufacturing process. That is CNC VMC.
And
That is
if for wooden furniture, it make a 3D printing like which is used that?
I'm not
Wooden furniture door designing, which software that mostly used?
wooden.
Yeah.
No, wooden material we can't use into 3D printing, na?
But in furniture store, which can use some doors or
But yes,
windows like in design.
we can create.
Yeah.
So anything you can use photopolymerization you can use in it. Okay, the plastic material from powder fusion you can create the door, but not the
Oh,
wooden. It is a
oh,
fiber based. No? Every material we have created here fiber based or plastic or metal.
oh.
Any formation for the metal, for the plastic, for rubber we can create. Here wooden metal is not there. No,
Yeah.
even wooden powder is not available here from any kind of 3D printing. These all are the techniques we are using into 3D printing. Okay.
Okay.
After that, now from tomorrow we are going to start our how to create a part for the 3D printer, and then how we are converting to 3D printing file, and then we are going to see 3D printer also. Okay.
Yeah.
In general, the student printers are available to market that is basically FDM based. Okay, FDM technology based. So we are working on the FDM technology from tomorrow. Okay. But I told you all types of techniques are available into the market. Okay.
Yeah, okay.
Okay, then this is done for today. If you have any doubt, you can ask me.
I can see the video, then only doubt clear. I will see the videos, then only I can any doubt I will ask.
First cross check all the types of 3D printing videos. Okay. If you have
Yeah.
any doubt in that, you can ask me.